Hello everyone, welcome to our 11th lecture of fluid mechanics and hydraulic machines. Today we are going to start our new topic and that is the mechanical gauges, which is I think the last topic of this chapter, fluid static or the fluids and their properties. Okay, so what is a mechanical gauges? Up to today's lecture, 11th lecture, we had discussed the different types of pressure measuring instrument. Okay, so that was the simple manometers. In manometers, we had seen the piezometer, simple YouTube manometer, single column manometer, and after that, in a previous session, we had covered the differential YouTube manometer. So that was the all about our manometers. Okay, you can see that from this classification, we had covered this piezometer. Okay, this piezometer, next is YouTube manometer, after that single YouTube manometer, after that YouTube differential manometer and inverted YouTube differential manometer. So these whole manometers are covered in the all previous sessions. So in today's session we will cover these mechanical gauges. So mainly there are four types of mechanical gauge. First one is burden tube pressure gauge, diaphragm pressure gauge, dead weight pressure gauge and bellow pressure gauge. So let's discuss these four pressure gauge, which are the direct indicator or the indicator of pressure. So what is the basic principle and the working and the construction of this mechanical gauges? So let's start from the mechanical gauges. As the manometer, which is already discussed earlier and suitable for comparatively low pressures, these manometers is suitable for comparatively lower pressure measurement, and therefore for measuring the medium and the higher pressure it is the elastic pressure gauges are used. They employ the different form of elastic systems such as the tubes, diaphragms and the bellows, etc. to measure the pressures. The elements are deformed within the plastic limit only, therefore these gauges are called elastic gauges or mechanical gauges. These mechanical pressure gauges, there are the different elastic materials which has a elastic property, and there is a limitation of this elastic properties so that we can use this pressure gauge or we can name this pressure gauge as a elastic gauges. So mainly there are the four types of pressure gauges. First one is burden tube pressure gauge, diaphragm pressure gauge, bellow pressure gauge and dead weight pressure gauge. So let's start from the very first, which is burden tube pressure gauge. So in this diagram you can see that the basic construction of burden tube pressure gauge, where there is a, from this bottom side we can see that the inlet of pressure, and there is a coke which is the opening and for the opening and closing of this valve. Next to this valve, there is the hollow block or the hollow line which is connected to this directly burden tube. This one is burden tube, which is metallic burden tube, and it can deform in a manner. This burden tube, which is connected to this tooth sector by means of this linkage mechanism. This burden tube is connected with this tooth sector. So when there is a pressure is when there is this gauge is you are using this gauge, the pressure is goes to this burden tube, and this burden tube is deflected towards this outer side, is deflected and it moves this tooth sector. By the moment of this tooth sector, it will rotate this pinion, it will rotate this middle pinion, and on this middle pinion there is a one pointer device like this. You can see that like this, which is our pointer device, and it shows the direct pressure on this dial indicator. So let's see the video of this. When there is a pressure is inserting, there is a simple motion of this metallic burden tube, and it deflects and rotate this tooth gear, and this tooth gear is rotate this pinion. This pointer is mounted on this pinion, which shows the pressure reading of this system. Okay, so this one is the basic principle and the working of this burden tube pressure gauge. Okay, so this pressure gauge, which is used high as well as low pressure measurement, there is a element. First is a metal tube, which is over here like this, which is the hollow metal tube, an elliptical cross section. When the one end of tube which is attached to this gauge case is connected to the source of pressure, the internal pressure causes the tube is expand. This metallic burden tube, it will expand, and the free of the tube in the moves, and it is in the turn connected by the suitable lever and the rack mechanism, which engages with the small pinion mounted on a same spindle as a pointer. Okay, so simply this one is a working of burden tube pressure gauge. Next, let's move towards the diaphragm pressure gauge. In the diaphragm pressure gauge, there is the same mechanism like our burden tube pressure gauge, but here it is the pointer which is the direct connected. Pointer mechanism is direct connected with this diaphragm. With this diaphragm. Okay. When your pressure get increases from this bottom side, the diaphragm get expand in this upward size. Okay, so this type of gauge is employs for the metallic disc or the diaphragm instead of bent tube in our burden tube. This disc or diaphragm is used for actuating the indicating device, which is used to actuate this indicating device or the pointer, which shows the direct pressure on this scale. When the pressure is applied on the lower side of diaphragm like this, you can see this in this animation, which is deflected in upward direction, and this movement of the diaphragm is transmitted to the rake and pinion mechanism. This one is our rake and pinion mechanism, and later is attached to the spindle of needle moving the graduated on dial. The dial can again graduate in the suitable scale. So let's see one simple video on this diaphragm pressure gauge. Here it is the diaphragm. When the pressure is applied on this diaphragm, it will deflect on the upward side, and the pointer is moved like this. So it is pure mechanical device, which is our diaphragm pressure gauge. Okay, let's move forward towards our bellow pressure gauge, and let's see the working of this bellow pressure gauge. Here it is the main components of the bellow pressure gauge. In this bellow pressure gauge, first one, there is the inlet of pressure in this direction. Middle portion, this one is your bellow, which is hollow from inside, so that we can put the spring. This connected with this connecting link towards sector, and sector is directly connected with this gear, and the gear, which one is needle, this one is pointer needle, and it is our scale that indicates the direct pressure. Okay, so let's see the working of this bellow pressure gauge. Here it is the spring which is used to regain its original position towards a zero. Okay, so now let's see the animation of this working of bellow pressure gauge. When you are, yes, when you are inserting the pressure, it will deflect your bellow like this. It deflect your bellow and shows the negative and the positive pressure like this. It shows with the negative also as well as positive pressure. Okay, so this one is your negative pressure, this one is your zero. Okay, so this bellow pressure gauge, which is used to measure the higher pressure compared to our atmospheric pressure and the lower compared to our atmospheric pressure. Next and the last instrument, which is our dead weight pressure gauge. That is our dead weight pressure gauge. In this dead weight pressure gauge, components of pressure gauge, we can say that this is a dead weight pressure gauge or the pressure tester. This one is not using for a pressure measuring devices, but it is the standard device which is used to calibrate any pressure gauge or any diaphragm gauge, any burden tube pressure gauge. So it is one kind of calibration device which is used to calibrate this pressure gauge. Okay, so this dead weight pressure gauge, or the second name is the dead weight pressure tester. So let's see the component of this pressure tester. First one is gauge or under test. This one is our pressure gauge. In this diagram you can see over here. Second is oil filled chamber over here, that is the oil filled chamber. Here it is the oil reservoir. Here it is the one valve. Second one, that is the weight over here, which is called dead weight. You can put in this diagram over here like this. Primary piston area of A over here, that is the primary piston. And the next component, that is the screw pump or the adjacent piston. It is our adjacent piston. Again, I'm repeating the term. Just listen that there is the dead weight pressure gauge. It is used to calibrate any pressure gauge with this device. So how it is used, let's see. When you are putting the weight of 5 kg over here, 5 kg weight over here in the dead weight, so we know about the force or the weight, that is the 5 kg. Also, this cross-sectional area of this cylinder is known, which is the area A. So area A, that is again known. So simply force or the load divided by area, this will be your pressure. So the pressure equals to force upon area. So when you are putting the 5 kg of load on this dead weight stand, it will directly shows the pressure of this pressure due to this 5 kg and the area. So we need to compare this pressure and this equation. If it is correct, then it is good, but it is not correct. If it is not correct, shows your pressure, then you have to change this screw pump adjacent piston and calibrate this device. So let's see how it's work. So first of all, there is a chamber which is oil reservoir valve. Over here you can see that there is one tester or a pressure gauge which is under test. Over here, that is the piston and weight. You can see that in this diagram there is a piston and weight. Standard weights are there. So here it is the 5 kg and two standard weights are there. Here it is the plunger which is used to maximize or the minimize the pressure in this whole system. And here it is the test gauge. Okay, so when you are opening this valve, there is a oil in this chamber. By putting the load on this system, the pressure is increases and the decreases like this. You can see that. And we need to compare this pressure with this standard weight. Okay, so you need to compare this pressure with this standard weight by this formula, like force or the weight of this element F divided by cross-sectional area of this piston XX over here. Piston or cylinder, there is a cross-sectional area. So suppose there is a 10 bar pressure, and in this pressure tester it also indicates you the 10 bar, then your pressure gauge is in a good condition. But if there is a change in a pressure compared to this 10 bar, then you have to calibrate this pressure gauge with this plunger device. Okay, so simply it is a dead weight pressure gauge which is used to calibrate any pressure gauge, that is a burden tube pressure gauge or diaphragm type or a bellow pressure gauge. So thank you. That was all about our today's lecture. You have to write down these four types of pressure gauges which we had covered today. First one is a burden tube pressure gauge, diaphragm pressure gauge, dead weight pressure gauge, and bellow pressure gauge. Write down these four of them and also with neat sketch and submit this your task to your Google Classroom. Thank you.